Well, hi, thanks for joining me in my shop. We're going to carry on with this Simplex radio, and the two things I want to do is explore the 6GS I-tube and discover why this is dull. This showed fairly brightly in my tube tester. Not so, it's really not visible in here. And just in case, I even have a replacement I-tube now that I can try putting in there. And I know this is a known good bright tube. So, but like I say, this one tested fairly bright in the tube tester. So part of that answer could lie in what has been done to the power supply in this radio. And that'll be the other thing that I want to work on is I want to make a diagram of the power supply situation in here, because let's turn it up this way. Because a lot has been done in there, and just looking at it I cannot sort out what exactly has been done. And so I'm going to develop the diagram here off camera. I'm not going to bore you with that process, and when I get it done I'll show you the result. We'll see what we can learn about what's gone on with this strange power supply and the mystery diode right here. Okay, so I've got a diagram here. Here it is. Can you tell I was once a drafting supervisor? Yes, I supervised for a couple of years a group of professional drafters. And, oh boy, hope they're not watching this video. So, I made 3 diagrams. Here's my first one. It's kind of pictorial for how things were laid out in the radio. And here's my next one. But here's the final one that we're going to talk about. So these are all the same. It's just this one is the easiest one to talk about here. So first of all, that's the power plug. That's the wide spade on the polarized power plug. And those are the 2 filter capacitors I installed to replace ones that were there, and that's the 1500 ohm resistor that's been installed also as part of this. So so I got a guess from Joseph that this was a this diode here, which is what we're so interested in, was part of turning this power supply into a full wave rectifier. And you know, that's a really interesting idea, because from what I understand, and I may not have this right because I may not have been looking at the right schematic, by the way, there should certainly be a field coil in the power supply right in this position here, or this one here, same thing. But the field coil is not there. And I also see that there should be a choke coil on the schematic I'm looking at, a field coil and a choke coil. That means the power supply filtering is highly dependent on these coils. There was probably a choke in here, or maybe out here, along with the field coil. You take all that away, and you got to do something about the power supply, because it's going to hum like crazy without them. So to compensate, the previous repairer created this rather typical, is this called a pi arrangement here, of 2 capacitors with a resistor in between. But the curious thing is, he's installed this, and by my reckoning, this is in no way is this a full wave rectifier. In fact, this is just 2 rectifiers in parallel, and that really raises the curiosity factor of what was the guy doing. So I don't know why he would do this, unless he thought he was creating a full wave rectifier and didn't understand what he was doing. He must have understood a fair bit. He's got a resistor in here to try to keep too much current from going through here. The only other thing I can imagine is, well, you know what, maybe this is you turn this set on, instantly you will start charging this capacitor through the diode and the resistor while this warms up. And we're only talking about a couple of seconds where this will then be warmed up, and it will then conduct a current. And then maybe this guy falls by the wayside at that point, because the current finds this path much more favorable. So maybe this is compensation for putting a big fat, he had 100 microfarads sitting here. And that 100 microfarad, the charging up of the 100 microfarad with no resistor in here would put quite a load on this diode as soon as it began to conduct. And unless I'm wrong, you get a couple of problems. You get like a flashover inside the tube. I'm not sure about that. But surely drawing a heavy current for too long will overheat the elements in the tube. So maybe that's what this is. This is a... You know what? This guy had a diode in this radio to create an instant on feature. And now I'm wondering if that diode, which was right across the switch here, I wonder if it worked in conjunction with this one. Well, this would be, well, even this isn't cold. With the diode across the switch here, there's enough current flowing to heat the heaters on all the tubes. But I guess the heating would be reduced. You know what? I really don't know why he's done this. But you know, someone out there watching this video knows. So I invite you with this information now to give me your opinion on why did somebody do this. I've certainly gone out and spoke my opinions out. You know what I usually do? I usually sit in the bush, keep my opinions to myself, raise the questions, and then let you think about it a little bit, because there's nothing better than getting more and more ideas rather than being stuck with the one you've got. And if I offer out my opinion all the time as to what I think I'm seeing, I'll just pollute I'll pollute your mind. That's what'll happen. I'll pollute your mind. I don't want to do that. So, but I've gone ahead and done it this time. So, what does this mean in terms of fixing the radio? Well, frankly, I think you could do away with this. The radio would work, except for that charge-up problem might be the case. You could do away with this at this point and just use the diode. Which is a really strange situation. It could be this resistor is trying to match the internal resistance of this to try to bring balance, because perhaps he's trying to split the current through here while the set is operating. Why someone would choose to do that, I don't know. During regular operation, there should be no more current going through here than there would be had the original power supply been in here. It shouldn't be any different. So it still stands as a bit of a mystery as to what's going on there. Now, the next thing is, what about the I tube? And I think the next step on that is to consider whether this is really the right schematic or not. Now this is the Model D. You can see it right there. And yet what I didn't point out on this radio is there's a paper sticker on the back that has the information I need to determine the model number and the serial number. But it's ripped off. It's been torn. Let's take a closer look at it and see if there's a hint on there. Just maybe. It's this piece of paper here. So there's a phone number, 702. That says INES, Ontario. That's the end of St. Catharines. And over here it says service laboratories. It has a P over here too. Maybe it's radio service something or other laboratories. Blah blah blah, St. Catharines, Ontario. So that's pretty similar to this sticker here, which is Ring Audio with a serial number on it. Looks like this sticker was put on by either the place that sold this originally or a repair shop. And you know what? Yeah, a repair shop. I was going to say it looks like there was a sticker on there before it, but I think what I'm seeing is actually the original sticker there. What's that over there? Hey, there's some more numbers here. 426067. 110 volts AC DC. 426067. Now these things have 4200, and that one is 42.6. So that certainly is yelling out that this is a Model D. And there's the power supply in the Model D. Just to compare it now, I might as well do that. So there's the rectifier. The plates are paralleled inside, so it's just a half-wave rectifier using both sides of this rectifier to carry the current. And then you see here's the field coil, and here's the choke coil. And then there's the capacitors, a 20 and a 4. So if this is the correct schematic, then that choke coil there, which I'm sure it says iron down there with a bit of the word missing, iron, this is a large thing, and there's nowhere on this radio for it to be sitting. So I don't know, I'm confused. Anyway, we now know what we got. We got this. And we can go on to the magic eye. Yeah, let's do that. Let's go on to the magic eye. What about that magic eye? Now I could just plug in the other one and give it a go, but somehow that seems too easy to me. I'm much more interested in what's going on. I think one thing we should check is what is the voltages. What are they supposed to be on a 6U5, 6G5, same thing electrically. The 6U5 has a different shape in the glass tube. I can't talk and work the alphabet at the same time here. 6U5. Used to indicate visually, by means of a fluorescent target, the effects of a change in a controlling voltage. Isn't that nicely set? Plate and target supply voltage. Low is 200, high is 250. Well, there you are right there. This thing's only got 130 volts. Series triode plate resistor, 1 megohm. And that's exactly what we saw in there. Triode grid voltage should vary between roughly 20 volts and 0. That's another thing we can look for. Is the grid voltage varying properly? So, a couple things. What is the plate voltage and what is the grid voltage doing as we tune the radio? So to do those tests, I got to get this radio operating. So I'm going to plug it in and get it ready to go. Okay, so I think I can account for the 5 wires that come from the magic eye tube, and I'll just show you what's going on here. Okay, so looking in at this mess of wires right in here, there's a hole there, you can't quite see it, and the wires are coming through from above. Well, there's 5 of them. They're all going to the magic eye. So 2 of them drive the heater, and that's these 2 down here. These 2 guys, they just travel down through the radio and hook up to heater terminals on tubes down in here. Now, this wire here comes up and just out of view of the camera here, it ties to the power supply, the final output terminal of the power supply filter. So that's where it's getting its B+. Trying to remember what the B+ was there. Just a little over 100, I think. Now, there's a black wire here, and this black wire just goes out and finds a ground terminal to get on. And there's this green wire. Yeah, isn't that suspicious? Hey, the green wire. How much do you want to bet that's the grid wire? What else is left? I think this is the grid wire, and it kind of comes around and connects here. right there. So don't be fooled. This, see how my camera's really, that's a beautiful example of why the camera can be so misleading. It really looks like this wire is tied into this connection, but in fact, no, there's a great big gap there. So, see, you know, same thing happens with your eyeballs when you're looking at these things. You can think a wire goes somewhere that it doesn't go. So let that be a lesson to you, viewer. Doubt everything you see when you see it in the camera. So what are we going to do about that? So I think we're going to turn on the... hey, there goes my furnace. Yeah, it's still cold enough up here for a furnace to run. Arr. Shouldn't be really anymore. Should be warm now. Such frustrations living in Canada sometimes. So these resistors are pretty curious. Connected in series, and they appear to go to this terminal here, which appears to be a ground point. Why don't we check that? Check it as soon as I can find my voltmeter, which is right in front of me here. There we go. So sometimes things that are easiest to find, when you're looking for something you think is hidden, you don't look in all the easy places. So here we go. So this one, no, not a ground. Yeah, I thought that was a ground point. It comes over to the volume control here. So I'm not sure what this green wire is. So what we're going to do is we're going to turn the set on, we're going to read these voltages, and hopefully discover this is actually the grid voltage, which is supposed to vary between 0 and 20. 0 and minus 20, I guess, to be absolutely correct, how to put it. So let's see what happens here. Okay, so I'm going to plug in the radio. It's our antenna there. And hope that this works. Hope we find out what these leads are. That's what I mean by that. Okay, so we're plugged in. Hey, we have no speaker on here. We have no speaker. Okay, it's going to take me a moment to get a speaker. Okay, so I was just going to connect up the speakers, and another little piece of the puzzle appeared. I'm going to show that to you. And this has to do with the speaker connections, of course. That's what these two clips are. They're going to my speaker that I put here. But I'll show you what I found inside the radio here. Okay, so this up here, which is not visible normally for a person sitting here working on a radio, it's hidden away. But that is the connector that you plug in the speaker. See from above. There it is from above. 4 pins, right? 1, 2, 3, 4. When you look up this way and you wait for the camera to go into focus, it's focusing through the little holes. Come on, camera. Get your act together, man. You claim to be a camera with autofocus, but boy, you just seem to have a mind of your own. Well, there it is, a blurry image. Anyway, there we go, there we go, there we go. And you can see clearly that the previous repair broke away the 2 terminals that are intended for the field coil. So you just remove them out of the radio, broke them away. Man, it's lucky you didn't break the whole piece, so you couldn't even plug in the other speakers. So what that shows is that's pretty precarious. Every time you plug the speaker in and out, there's a chance this thing's going to give up the ghost. I thought that's kind of interesting, and that's where I have to clip on my. Since I'm going to try to do this from inside here. It's really not the best spot to try to put a clip in there. Okay, that looks good. I guess I could follow those wires back and clip at the other end of the wires somewhere else in the radio. I think that's going to work fine. So I think we're just about ready to, let's get this out of here. Hook up my hot chassis lights. Okay, are we clear for takeoff? Looks good. Okay, so I gotta remember it. Between the last time I worked on this radio and now, I've worked on at least 4 other radios in the meantime. And I've gotten myself all confused about the dials here. Band, here, volume. Okay, and off. Okay, so it's switched on. A little squeaky. Switched on, and speaker connected, and antenna still coiled up. That's okay. We're just going to measure some voltages. Okay, so we'll put the voltage on low. There we go. I guess I gotta get my voltmeter ready here. Okay, so first, and I'm still on restricted voltage. Let's check the B plus voltages. One side's 103, 88. So 88 is what is going to the plate of the Magic Eye when it's really looking for between 200 and 250. So boy, that is way low. You know, what were they thinking when they put a Magic Eye in here? I don't know how the B plus could be any higher, really. Well, you know, you could get it higher if you took it off the other. Yeah, maybe that's what we'll do. We can move it to this other pole. You go from about 90 volts to a little over 100, so you get about a 15 volt boost. And if I take this off restricted power, this voltage will jump up to about 130. And 130 is a lot different than say 100 that it's been running on. So that's one thing we could do. Now, what is this? Here we go on the green wire. Minus 0.6. So I'm pretty sure that's the grid. And this shouldn't affect the brightness of it at all. What this should be showing is right now, with the radio's not receiving anything. I assume it's not receiving anything. Hey, there's no sound coming out of it at all. Really? I think this is the volume. No sound at all. Don't like that. How come? Everybody stop. What have I done? Well, maybe my speaker connections haven't worked. Excuse my head. Hard to believe. Hard to believe. Voltage too low. turn this wee bit here. You can see the can't see much of anything there, can you? Our voltage is around 122. That's what the set's being supplied with now, 122 volts. Let's check it out. So you got 120 volts now, and the tube would be running on, looks not even 100, 96 volts, just 96 volts. So that's why the tube would be dull. That's one possible reason anyway. Another possible reason is these tubes are actually, like a lot of tubes, two tubes in one. This one has a triode in it, and then it has the actual magic eye glowing part. And the purpose of the triode is to kind of isolate the magic eye part away from the rest of the circuit, because it requires, for whatever reason, I don't know the exact reason. So the triode stands in between the radio circuit and the glowing part of the eye, so to speak. So if the triode's weak, then you may not get the response you expect. But again, it shouldn't change the way it's glowing. The glow is from lack of voltage, I'm quite sure. Which means changing the tube really shouldn't make any difference, and it also means the tube never ever worked, which is ridiculous, right? This is just a ridiculous concept that these radios were made with magic eyes that didn't work to begin with. That just doesn't make sense. So, and it could be, a brand new magic eye in top shape gives you a fighting chance at a low B+ voltage. And then as it gets older, unless you put it into a higher B+ voltage circuit, it's just not going to do the job, even though it's still alive and essentially well. Not so well on this particular radio. Okay, so I really want to put a signal into it and see that AVC operate. So let's do that. We'll see what that voltage goes to. I'm calling it an AVC voltage. I don't know that it's, well, it's almost certainly acting as an AVC signal throughout the radio. If they were smart enough to figure out how a magic eye worked, then they would be smart enough to figure out how to do AVC. So I'm sure there's AVC in this radio. Automatic volume control. Okay, so we've got a signal coming out on our signal generator here. Right there. 15, that's a little high. Put it there. Oh yeah, no volume. How's this going to work with no... Oh! Yeah, I see. I had it on low voltage, and I guess it just wasn't heating up enough, so... There we are. Let's put it on AM band. Okay, that's the AM band. Sounds good. We don't have a pointer anymore, but I can look at the plates and kind of figure out roughly where we are. Plates on the capacitor. So I'll put this kind of down in the middle here. Okay, so that's going to be around 1,000 or something like that. Come on. What's happening? Hey. Come on, little radio, you were working before. Oh, you know what? We could never tune this radio past a certain point because the pointer was colliding with the damaged dial backing. The dial, decal, I don't know what to call it. The dial. And so I've never tuned the radio this far back, I don't think. up where it was working before. I don't know why it wouldn't work in the other place, but let's try it. There it is. Not very strong. Oh, well, let's check that AVC voltage now and see what it does. What we think is the AVC voltage. Let's see what it does. So we think it's right here, -2. Now we'll tune this through. And there you see the change in voltage. So it starts out at -2. With the signal into it. -4. And I'm pounding in a pretty good signal here. Sure doesn't sound like it though, does it? Hey. Okay, everybody stop. Nobody move. How do we get a big spark there? I'm a scaredy cat now. See, I wonder if that got on camera. So, that was a little odd. All kinds of warning bells are going off here. In my head, anyway. So my lead here, which is connected to the antenna, connected to my signal generator, just kind of slipped down my shop and crossed over the speaker leads, and a rather surprisingly large spark came out of it. Okay, I think I'm on the verge of learning something here. Let's check a few voltages. So first of all, what's going on these speakers? I'm watching my voltmeter here. What? Hey, that's not good. What? Why, is that just the, what is that? That's on the DC scale. A lot of meters can't separate AC and DC very well. Let's put it on the AC scale. See, as soon as I touch it, it gives, first reading is a very high reading. Watch now. As if I'm bleeding off a charge. And that spark, it looked like a capacitor discharging to me. And it probably discharged by dragging over the ground here, the ground connection. The ground connection is 0 to ground. Of course, the live connection is to the. So it looks like I dragged a ground across a speaker lead with a stupid amount of voltage on it. Wow, I wonder what this means. Does this mean the guy who... the guy's trying to kill me, the guy who worked on this thing. That's what it is. He set up all kinds of death traps in this radio. Starting right with the chassis being live. but I have my hot chassis light on, and you know, there's no voltage on the chassis. Let me just double check that, because occasionally I am wrong about things. So no, there's no voltage. That's reading the radio chassis to ground. Well, you know, the thought that comes to mind, the loose thought, is that the guy didn't quite unwire this radio right. Why, you know, oh my lord, did he hook it up so that the B plus is going right through the speaker? Mysteries, do they ever stop? Okay, maybe I'm the goofball here. You know, one of the things I concluded when I started doing this videoing, one of the things I realized was I was going to make mistakes, and they're going to go on video. And I'm going to have to decide whether I leave those mistakes on the video and look stupid. Look stupid. When you make mistakes, you look stupid. Or whether I would remove them all so you'd never see any mistakes that I made. And my choice, just because of the practicality, was just to let everything go through that happens, even if I make dumb mistakes. So I guess you can tell I'm winding up for a dumb mistake here. Now, many of you already know what the dumb mistake is, and I seem to be prone to this one because I did the same thing on another radio just a few videos ago. I forgot that the output transformer is sitting on the speaker in the cabinet in the other room. And this radio is sitting here with no output transformer, and I'm the idiot who connected the speaker straight across the output of the tube, running the B plus through my little speaker there. I'm a dummy. So I'm telling you this on account of, here, I'm going to shut the set off, on account of don't you make the mistakes I make. So in the end, I have decided to let everything go through. If you watch enough of my videos, you've seen me get injured in here. There's one of me getting a shock in here. So I'm letting all this come through, and I'm hoping it's understood by you that the mistakes I make are typical of mistakes made by people doing this kind of work, especially when they're trying to video it and talk about it and do 3 things at once with their brains. So my brain only has the capacity of doing 2 things at once. When I get up to 3, I'm in big trouble. In fact, I'm in trouble at 2. Okay. Now, I've talked myself down from the utter embarrassment of having done what I did. I'm going to have to go get the real speaker and connect it up here properly. Oh my, you know what it is? Not enough coffee. That's what it is.